Guys, this video is all about scientific notation. This is probably one of the easiest 8th grade math or algebraic kinds of operations that you guys are going to do in the 8th grade next year. Scientific notation is a short way to write a really big or a really small number. So scientists came up with a way for them to write numbers without having to write all those zeros that we know that we have to write when we're writing decimals, or all those commas when we're writing really large numbers. Okay, so guys, let's start off with looking at a couple of examples. First thing I want you guys to notice is that scientific notation is broken into parts. This is what scientific notation looks like. You usually have a number right here, and that number right here can usually contain a decimal, or it can be a whole number. And then you have this old school times symbol that we probably haven't used in a long time, probably since 5th grade. And then you always have a base of 10 and a power. Whenever you have scientific notation, you have to have a base of 10 and a power. The power could be positive or the power could be negative. Guys, something else I want you to know about the number that comes in the front of your times symbol. This number has very specific criteria. This number has to be 1 or greater, but it has to be also less than 10. So basically what I'm saying is the number can be bigger than 1 or bigger, but it has to be 9.99999. It cannot be bigger than 10. If you come across a number that looks like it's written in scientific notation, like 10 times 10 to the 4th power, you should know that this is not in scientific notation, because this number is greater than 10. Remember, it has to be less than 10 or greater than or equal to 1. Okay? So guys, this number is in scientific notation because it fits the criteria. It's 8.1, which is greater than 1 but less than 10. Okay? Let's look at how we're going to take numbers like 8.1 times 10 to the 4th power and change it from scientific notation to what's called standard form. Standard form means that you're just taking the number and you're making it with either a decimal or with all those commas. Okay? The exponent will tell you guys which direction to move your decimal point, and it will also tell you which direction and how many times to move your decimal point. Okay? So if it's telling you you've got 10 to the 4th power, what you're going to do is take your base of 8.1, and because 4 is a positive number, that tells me that I need to move my decimal point 4 places in a positive direction. So I'm going to move it 4 places to the right. 1, and when you run out of spaces, just add zeros. 2, 3, 4. So what used to be 8.1 times 10 to the 4th power is really 81000, or 81,000. Okay? Let's look at a couple more examples. Let's look at 4 times 10 to the 3rd power. Is 4 greater than or equal to 1 but less than 10? Yes, it is. So I'm going to take my base of 4, because it is in scientific notation, and I know that I'm supposed to move my decimal point in a positive direction 3 times. The natural decimal point in 4 is right here, and I'm going to move it 3 spaces to the right. To the right. 1, 2, 3. And in all those spaces, I could just fill in 0, 0, 0. So what's 4 times 10 to the 3rd power is really 4,000. Okay? Let's look at a negative exponent. Here's the same scientific notation problem from before, but this time 10 is being raised to the negative 3rd power. So instead of me moving it 3 places, moving the decimal point 3 places in a positive direction, I'm going to move the decimal point 3 places in a negative direction. So my natural decimal point for 4 falls right here. And I'm going to move it 3 places to the left. 1, 2, 3. And in all those extra spaces, I can just fill in zeros. And if you want a placeholder, you can put a 0 right there as well. So it's 0.004. Or how we would read this, like 8th graders, we would read this as 4 tenths, hundredths, 4 thousandths. Okay? Alright. Let's look, guys, at a couple more examples of turning numbers into scientific notation. 3.5 times 10 to the 6th power. Alright? Is this in scientific notation? It is, because 3.5 is greater than or equal to 1, but it is also less than 10, so it fits our criteria. So we're safe to turn it into standard form. We'll take 3.5. Let's look at our exponent. It's 10 to the positive 6th power. Positive 6 means we need to move to the right. Take your decimal, move it in a positive direction. 1, 2, 3, 4, 5, 6. Fill in the rest with zeros. So it's 3, 5, 0, 0, 0, 0, 0, or 3,500,000. Okay? Let's look at this example right here. 11 times 10 to the negative 2nd power. Is this in scientific notation? If you said yes, that's wrong. No, it is not. Look at your base of 11. Is 11 less than 10? Of course not. 11 is not less than 10. So guys, let me show you something that you need to do when your number is not already in scientific notation. If it's not in scientific notation, you need to put it in scientific notation before you decide to put it into standard form, okay? So this is a little trick that you can do to take your number and turn it into scientific notation. What you need to do is ask yourself, how can I get 11 to be smaller? And what we've been doing is just moving the decimal point. So we're going to do that. I'm going to take 11, what used to be 11, the decimal point is right here, and I'm going to move it one space to the left. So now it reads 1.1. But if you change your number here, you also have to change your number here. Since I made 11 smaller, I have to make -2 bigger. How many times did I move my decimal? Once to the left. So I need to add the one space that I moved from 11 to make this 1 bigger. What's 1 bigger than -2? Don't say -3. It's -1. So when you make your base smaller, you make your exponent bigger. So it will be just the opposite the other way around. If you had to make your base bigger, which we do because we know that 12 is less than 0.12 is less than 1, then that means you have to make your exponent smaller. So how can I make 12 bigger to fit the 0.12 bigger to meet the criteria? I would move the decimal point one place to the right to get 1.2. And since I made this bigger, I have to make this exponent smaller. What's 1 smaller than 3? 2. Okay, so guys, please remember that your criteria is very specific. It has to be greater than or equal to 1, but less than 10. Okay, let's look at some examples over here, guys, of some numbers that we're going to take and turn back into scientific notation. Guys, remember that the criteria is very specific. You'll know where to stop your decimal because the number will be greater than or equal to 1, but less than 10. So, for example, you got 0.001436. There's a certain place where I need to stop my decimal to see where the number is going to be greater than or equal to 1, but less than 10. Okay, let's move it. First of all, which direction do I need to move it to make it big enough? To the right. Once 0.01436 is not greater than 1. So I'll move it here. Is 0.1436 greater than 1? No. How about here? 1.436. That's greater than or equal to 1, so we can keep that. 1.436. How many times did we move the decimal? 1, 2, 3. When your number that you began with is less than 1, your exponent will be a negative. So this is the power is going to be negative. Now when you look at 5001, this number is greater than 1. So this exponent for this number is going to be positive. the natural decimal point in 5001? It's back here. Let's see how many times we need to move the decimal, because I know that's greater than 10. If I move it right here, it would read 500.1, still greater than 10. If I move it here, it would read 50.1, 50.01, which is greater than 10. But if I move it here, it reads 5.001. That's less than 10, so it meets the criteria. So your number should be 5.001 times 10 to the third power. We can even write numbers like 100 in scientific notation. Natural decimal point is right there. Let's move it. That's 10. Can't be equal to 10, has to be less than 10. So if we move it here, it's 1. You can write 1 times 10 to the second power. Why is it positive? Because your number was greater than 1. And lastly, guys, you got the small number right here, so we already know that your exponent is going to be a negative. Let's move the decimal. 2.579? Yeah, 2.579. That's greater than or equal to 1, but less than 10. How many times did we move the decimal? Just once. So 2.579 times 10 to the negative first power. Okay, guys, I know I kind of stumbled through that, but it's early in the morning, so if you have any questions, make sure that you inbox me. Thanks, guys.